More at graphing of the sine and cosine graphs today, and looking more at the translations, those things that we kind of saw back in the last section. We're seeing what's happening with these bx minus c pieces. How are these things going to affect the graph? Okay? And what happens is that we know the graph is going to complete one cycle, or it's going to run through one period of the graph, from bx minus c equals 0 to bx minus c equals 2 pi. That's how we're going to figure out a starting point and an ending point for our cycle, for our period of the graph. So by solving for x, we find an interval for one cycle. We know where to start and where to end. And we're going to find the key points in that cycle by dividing the interval into fourths. So we're going to find half. Where is the middle? And then where is the middle of the first half? Where is the middle of the second half? And we're going to use those key points at the fourths of the period to sketch our graphs. Okay? So if we look at the first one here, we've got y equals 1/2 sine of the quantity x minus pi over 3. So we need to look at a couple of things. Number one, we need to know what's the amplitude. We need to know our b value, because that's going to tell us something about our period. But more importantly, we're going to use that x minus pi over 3 to get the period. Okay? So here our b is 1. Our a is 1/2. So we know our amplitude will be 1/2. So to look at that period piece, we're going to take x minus pi over 3, set it equal to 0, and set it equal to 2 pi. Okay? Kind of running off the screen there a little bit. There we go. So here we get x equals pi over 3. And here, when I add pi over 3, that would be 6/3 plus 1/3. I'd have 7 pi over 3. I'd have 7/3. Okay? So what does that mean? So we're going to use those as kind of our beginning and our end to our graph. Okay? So I'm just going to go here and I'm going to put pi over 3. And I know I'm going to go out, I'm going to end at 7 pi over 3. And if you look, that is a distance of 2 pi. If I add 2 pi to pi over 3, I end up at 7 pi over 3. Okay? And now we talked about those key points. And the key points come by finding the middle and then the fourths, the middle of the front half and the middle of the back half. Okay? So how do we find the middle of pi over 3 and 7 pi over 3? Well, we're really just taking the average. So I'm going to take pi over 3 plus 7 pi over 3, which is 8/3 pi, and I want half of that. Okay? Well, if I take half of 8/3, that's 4/3. So my middle is at 4 pi over 3. Okay? And I'm going to do the same thing in this first period. I need to know, what is this value here at the 1/4? So what is the middle of the front half? Well, if I take pi over 3 and add 4 pi over 3, I get 5 pi over 3. And half of that is going to give me 5 pi over 6. I do the same thing on the back end. 4 plus 7 gives me 11 pi over 3. Half of that puts me at 11 pi over 6. Okay? So those are our key points. Okay? Now we need to look at the amplitude. Okay? I'm going to go up here is 1, and here is -1. Our amplitude is going to be at 1/2. We have a sine function. Okay? So we know that when we start a period, and we referred to this in the last section, I alluded to these things. Okay? With the sine function, it begins, ends, and right in the middle at a y value of 0. It's going to be on the x-axis. Okay? And then here at 5/6 pi, kind of that 1/4 mark, that halfway between the first half, it hits the amplitude, the maximum. Okay? So that's going to be up here at 1/2. And then over here at 11/6, where it's halfway between the second half, I'm going to hit my minimum, which is going to be kind of covered up here. So I'm going to have to move my 11/6. I'm going to put that 11 pi over 6, because now I need to be down here. And now here is one period of the graph, y equals 1/2 sine of x minus pi over 3. Okay? And really, if you think about where the original sine function was at, the original sine function started at 0 and it ended at 2 pi. So if you look at the x minus 3, we've really translated, or we've shifted this sine graph to the right pi over 3 units. So instead of starting at 0, 0 where we were before, we shifted every point. We slid the whole graph over pi over 3 units. Okay? And that's where that translation comes in. Okay? We just didn't look at it in the same fashion, because with all these fractions in here, it's a little bit more difficult to say, okay, we're just going to slide everything over pi over 3. But that's really what is happening with all this work that we're doing down here, figuring out where the fourth is, where the half is. All of that is just that transformation stuff that we talked about with other graphs earlier in the year. Okay. All right, next example. We have y equals -3 cosine of 2x plus 4 pi. Okay, so first thing is, what's our amplitude? Well, remember, amplitude comes from the coefficient on the trig function. Okay, so our amplitude is going to be 3. What do you think the negative is going to do to the graph? Okay, it's going to reflect it in the x-axis. So where we used to have maximums, they're now going to flip over to minimums. Okay, and where there used to be minimums, they're going to flip up to maximums. So we've got this translation going on here. So we're going to take 2x plus 4 pi equals 0, 2x plus 4 pi equals 2 pi. Okay? And we need to solve both of those for x. So 2x equals -4 pi. So x is -2 pi. And over here, 2x equals -2 pi. And when I divide by 2, I get x equals -pi. Okay? So from -2 pi to -pi. And that should jive with our concept of b. Our b value here is 2. And remember, our period was 2 pi divided by the b, which gives us pi. Well, from -2 pi to -pi is a distance of pi. So there's our period again. Okay? If I look at the distance between these two values, that's simply a distance of pi. So I'm going to come over here, and my graph is going to start at -pi. I'm going to run it out to -2 pi. So where's the middle? Well, the middle would be at -1.5 or -3/2. Where is the fourth? Okay. Well, if I look at these, -3/2 plus -1 is -5/2. And I want half of that because I'm dividing by 2. I'm taking the average. And I got -5 pi over 4. -2 pi plus -3 pi over 2. Well, -2 is going to be -4/2, so that's -7 pi over 2. And divide by 2, which means multiply by a half, gives me -7 pi over 4. So that's this one. Okay, -7 pi over 4. And that's going to give us one period. Okay. Now, our amplitude is 3. Okay. So if you remember the cosine, the original cosine of x started at 0, 1. It started at its high point at +1. Well, this one you would say, okay, the amplitude is 3, it should start at +3. But the negative out front here is going to flip the whole graph over, which means now my starting point is going to be at the minimum, which means my ending point will be at the minimum, just like the original cosine. And in the original cosine, the middle was at the minimum. Now it's going to be at the maximum. So what happens at the quarter way point? and the 3/4 point. In between those is where it's at its zeros. Okay, so it's going to go up, down, and here. Okay. And there is one cycle or one period of that graph. Okay. Now, if we wanted another period, we could go farther to the right. I know the period is pi. Well, there's negative pi, so if I go back here, here's 0. Okay, so here's a half of that, and a quarter, okay. So I know at the halfway point, I'm going to be back up top. Okay, at 0, I'm going to be back down here. My points here, so I come up, come down, okay. And it kind of got a little squished together because my spacing's not exactly the same, okay. But here's my negative pi over 2, negative pi over 4, negative 3 pi over 4, and now I've got 2 periods, okay. So in here, okay, here was 1 period, and then here I've got 1 period, okay, and the graph would really just keep repeating itself, and it would just keep going, okay, and we could figure out what all those values were at the highs and the lows and the zeros. Alright, y equals 2 plus 3 cosine of 2x. So this first thing, let's figure out what's our amplitude, what's our b value, okay, and what's our period. Okay. And notice this one has something extra. It's got a little 2 out front here, so we have to think about what's going to happen with that. Okay. So our amplitude is the coefficient. That's 3. B is the number in front of x. B is 2, which means my period is 2 pi divided by 2, which is pi. Okay. Notice I'm not adding or subtracting anything to the x term here, so I don't have to set it equal to 0 and 2 pi to figure out where it starts and stops. Okay. But I do have this random 2 out in front, this constant. Okay. Well, if the thing's being done to x, like always, we're shifting the graph left and right, then the constant out here in the front is shifting the graph up and down. Okay? So rather than having that cosine, which was start going from 1 to negative 1 and kind of doing this number here, okay, that positive 2 out in front is going to take my whole graph, okay, if I can get it to work here, it's going to take the whole graph and it's going to slide it up 2 units. So instead of starting at 1, if I slide up 2 units, now I'm going to be starting at 3. Okay. And my amplitude is going to be 3. Okay. And that makes sense because that starting point for the cosine is kind of the high point of the graph. Okay. All right, so let's see how this is going to play out here. We know that the period is going to be pi, so I'm going from 0 and I'm just going to come out here and call that pi. So I need my key points. I need my halfway, which would be pi over 2. This one works out nicely. I need the middle of the first half, which is pi over 4, and the middle of the second half, which is going to be 3 pi over 4. Okay. And we're going to go 1, 2, 3, 4, 5. Let's just go up to 6. That way, stretch out that way. Okay, so let's kind of plug some values here and look at a table here. If I put in pi over 4, okay, then I'm going to have 2 plus 3 cosine of 2 times pi over 4. Well, 2 times pi over 4 would be pi over 2. And what is the cosine of pi over 2? That's 0, so that's all gone. And I end up at 2. Okay. So at pi over 4, I'm at 2. I put in pi over 2. And I have 2 plus 3 cosine of 2 times pi over 2 gives me 2 plus 3 cosine of pi. Well, what is the cosine of pi is -1. So I have 2 minus 3, which is -1. So at pi over 2, I'm going to be in here at -1. I'll change colors here so we can see. There it is. There it is. So now let's think about what's happened with this positive 2 here. What that positive 2 has really done for us is said, okay, instead of 0, the y equals 0 being kind of our middle of the road with our maxes and mins above it, it says I'm going to take that and I'm going to shift it up 2. So really what happens is, when I come up to positive 2, that's kind of my middle of the road. Okay? My amplitude is 3. So if I were to put in, let's put in 0. Let's see what happens at 0. Okay. Well, 3 cosine of 2 times 0. Well, the cosine of this would be 0. So that's going to be 2 plus 3, which is 5. Okay. So I'm starting way up here at 0, 5. Okay? Because my amplitude was 3, so that would move me, instead of starting at 1, it would start me at 3, but then that 2 out front says take the whole graph and now shift it up 2 units. So instead of my starting at 3, now I'm going to shift up and start at 5. Okay. And notice that is 1, 2, 3 units high. My -1 down here is 1, 2, 3 units low. So where do you think we'll be at 3 pi over 4? At 3 pi over 4, we're going to be back at what we're now considering kind of our 0 line, our middle line. And when I get to pi, I'm going to be back up here at that high point. Okay? We're kind of crossing up all of our stuff here, but this is kind of where the graph is going. Okay? So we could kind of use a combination of this idea of key points, but it's also a good idea just to use an input-output table of those key points to make sure that everything's in the right place. Because it gets a little bit more tricky when we have this constant out front that's going to shift our graph up and down. We have to think about my amplitude changes, but now I'm going to translate it and move it up even higher. Okay? And we'll look at some more of these when we get to class. Alright, let's kind of shift gears here and see if we can kind of go in the opposite direction. So take a look at this graph. I'll give you a minute to think about it, and we're going to look at amplitude, period, and phase shift. Okay. So if we look at the graph here, notice that I've got a point at 0, the beginning, the middle, and the end are all on the 0. Okay, that tells me that it's a sine curve. Okay. The amplitude, where are our maxes and mins from that 0 line? Well, they're 2 units. Okay, so my amplitude is 2. The period. Well, if we look down here at the bottom, we're not exactly counting by ones anymore. So I got pi over 3, 2 pi over 3, 3 pi over 3. So I'm guessing each small line here, 1/6. Okay, this would be pi over 6. This would be 2 over 6, which is pi over 3, 3 over 6, 4 over 6, which is 2/3. Okay. So back here I've got negative 1, 6, negative 2, 6. This would be negative 3, 6, so this would be negative pi over 2. Okay? This is 3/3, or 6, 6, 7, 6, 8, 6, 9, 6 would be 3 pi over 2. So what's my period? My period is going from negative pi over 2 to 3 pi over 2. So how far is that? Well, what's the distance? Well, that's going to be a half plus 3 halves is 2. So I still have a period of 2 pi. But I have a phase shift. Okay? Normally, the sine function starts at 0, 0. Okay? This one has been backed up to negative pi over 2. So my phase shift is going to be a negative pi over 2. Okay? So how do we put all these things together? Well, y equals, okay, it hasn't moved up or down, so I don't have a constant. My amplitude is 2, but notice that the graph doesn't start by going up like the normal sine. It starts by going down. So that means I have a negative 2 coefficient in front of my sine. Okay. My period did not change, so I still have x. And the phase shift was negative 2. I went to the left, which means I'm going to have plus pi over 2. Okay? So there is the equation for this graph that we have right here. And I think we'll skip that. We're gonna talk some more about this stuff in class. Okay, so in class, we're going to go and do more looking at these graphs and doing some more of these graphs together so that we get the hang of looking at these phase shifts and these changes in amplitude and how we can use that information to sketch the graph, or maybe take the graph as we looked at in that last one and come up with the equation. So we'll see you tomorrow.